When the Dream Day project was assigned, I thought about a lot of different options of things I could make. I didn't know what I wanted to do, but I wanted something that was fun, that moved, and was functional. I thought about making an electric or motorized wheelchair. I thought about making an electric or motorized car. I thought about making an electric bike. Unfortunately, every idea I came up with, including the idea I finally decided to try, involved welding. After watching dozens of YouTube videos, I finally found a drift truck that didn't involve welding. It was made almost entirely out of PVC piping. My dad told me it was going to be too expensive to make though. So I thought I should try to make one that was a hybrid of wood and metal ones that I found, using some used and some new parts. I made a sketch of what I originally thought my trike should look like. Then my dad and I came up with ideas for how we could build it to work. I pulled wood from our scrap pile, set up the sawhorses to make a workbench, and pulled out the tools I thought I would need. We looked online for a used spike that we could cut apart to make the front end of our trike. Because the idea wasn't something that I found on a YouTube video, it turned out that every step of my project was going to take longer and be even harder than I thought. My first step was to find a cheap bicycle that I could use for parts. After looking on Craigslist and Marketplace, not at school though because all of the sites are blocked, I found someone selling one in Bartlett. We picked it up the next day and I started taking it apart. The pedals came off easily enough, and so did the chain and the bike seat. The back wheel, however, proved to be very difficult to take apart. The brake assembly connected to the back wheel was also connected to the main parts of the bike and couldn't come off in one piece without damaging the bike. After working on it for over an hour, we ended up having to cut the brake line, which meant we couldn't reuse it later. Then, when I tried to cut the downshoot, it was hard to keep the angle grinder steady, and I cut it in the wrong spot, which meant the bike wouldn't be able to support the weight, and I had to move back to square one. After more researching, I found another bike that my dad picked up on his way home from work. The good thing about the second bike was the fact that it had footrests already mounted to the front wheel, which meant I wouldn't have to build footrests for the drift truck anymore. The second time I was able to cut the downshoot correctly. Then I used a different attachment of the angle grinder to smooth out the rust spots where the metal was cut. The next step was to remove the ball bearing and grind out the two races inside of the crankshaft housing, where the pedals on the bike used to be. I needed to be able to put a rod through there so I could mount the front end of the bicycle onto the platform I planned to build. Again, this step ended taking up way more time than I had thought it would. I spent almost 15 hours over the 3 days grinding out races using a curved 80 grit chisel followed by a 160 grit chisel. When it was cleared out enough to put a rod through, I used a sandpaper to make the wall smooth as possible. The next step was to find a 2 3/4 diameter rod that would fit into the now cleared crankshaft housing because I need a way to mount the front end of the bicycle to the platform I planned to sit on. Home Depot did not have any 2 3/4 rod, but I did find a metal pipe that was the right size. Once I figured out how much longer the pipe extended on either end from the crankshaft housing, I used a chisel to carve out 2 semicircles into 2 pieces of wood so that I could connect the front end of the bike to the back platform. It took my grandpa and I about 10 hours to hand carve all these semicircles together. After we made sure the pieces all fit, we smoothed the surface with sandpaper, then inserted the pipe into the crankshaft housing, rested the pipe and the housing into the bottom semicircles, placed the other semicircle on top, then bolted the wood together. Now that I had the front chassis of the trike finished, I could move on to the back of the bike. The back consists of everything that makes the bike move, including the axle kit, the motor, and the chain that connects the two. I didn't know when I started how difficult and time-consuming this part of my project would be. I worked on it for at least 2 hours a day for the next few weeks, and still wasn't able to get it working the way I needed it to. First I started to assemble the axle kit that we had ordered online. It ended up very hard to do by myself, and so I asked my dad and grandpa for help. When they couldn't figure it out either, we spent about 3 hours researching and finally got a put together after I found a video that walked us through the steps one by one. After the axle was finally done, I built a rectangular base out of 4 2x4s I cut. I mounted the axle on it, then connected that component to the front chassis. I had seen a lot of videos online that use drills to power equipment, so I decided to use one of the hand drills from our garage to power my trike. Later on, that decision would give us even more problems. First, I had to figure out how to make a platform that I could mount the clutch assembly on. I found a sheet of wood that was about 1 inch thick and then measured and cut it so that it was long enough and wide enough to sit on top of the rear base I had built. After that, I cut a rectangular opening in the same board so that I could feed the chain through between the motor and the gear sprocket that was on the axle. Next, I cut 2 2x4s the same length and stood them on end on either side of the rectangular opening. The first time I tried to screw the 2x4s onto the platform, I didn't drill wide enough starter holes and the screws stripped. And because I couldn't get the screws out of the board without stripping them, I had to throw away the entire thing and start again. The second time, I cut the platform with the rectangular opening, cut 2 more 2x4s, and was more careful about my pilot holes for my screws. This time the screws went in without stripping, but the platform split and I had to do a third platform. This time I not only used the right size pilot holes for my screws, but I also used soap on my screws to make them go into the wood with less resistance. The third time was completely successful and I was able to finally mount the platform and the 2 2x4s onto the base. The next steps were pretty easy. I screwed the pillow bearings onto the top of each of the 2x4s, then put a rod called a drive shaft through one side, fed the shaft through something called a centrifugal clutch. A centrifugal clutch is basically 2 gears, one that is always spinning when the other is only spinning when at high speeds. The goal was to put one end of the drive shaft into the drill opening, but the drive shaft ended up being too big in diameter. My dad called a CNC business in Bartlett and asked them if they would be willing to grind out about 1 inch of the length of the drive shaft to a 3/4 inch diameter that would fit into the drill opening. When they said yes, my mom and I drove over to a man by the name of Adam at AGH Tech. Adam walked my mom and me through the shop to show me some of the machine equipment. They said to come back later in the evening to pick up the drive shaft. We ran home and baked 3 apple strudels to thank Adam and his team for their help, since they wouldn't take money. When we got home, the drive shaft fit perfectly into the drill. So I fed the drive shaft back through the 2 pillow bearings and the centrifugal clutch and gear. I took the bike chains we had kept from the used bikes, took a link off of it using the Dremel tool, fed it through the rectangular opening in the platform, and wrapped it around the gear sprockets into the center of the axle. Then I took both ends of the chain and held them together at the top of the gear that was next to the clutch at the top of the 2x4s. Needle nose pliers helped me reconnect the 2 ends of the chain, and I was finally ready to attach the drill and try the trike for the first time. I very excitedly switched the drill to the on position and pulled the trigger. But although the drill turned the drive shaft, it did not turn the clutch, or the chain, or the axle, or even the wheels. After trying the drill desperately in forward and reverse, checking to see if the clutch was locked up, and running through a checklist of everything that could possibly be wrong, my dad called my uncle to explain the problem. Turns out that my drill wasn't powerful enough to turn my trike. I'd like to say that we immediately went out to buy a Honda motor or buy an 1000 RPM spring instead of a 2000 RPM spring for the clutch, or that I sat down to figure out a new way to power my drift trike together. Unfortunately, it was due the next day, and with all of the issues, I had run out of time to get it working. Not for lack of effort, though. I am going to finish my drift trike over the winter. The things I still need to do once I figure out the one with the power situation are to build the seat, build housing for the drill so that my hair can't get caught in the chain once it does work, deflate the tires and reinflate them into PVC pipes so that they drift on the pavement, and paint the entire trike so it looks a little nicer. I did learn a lot during this process about the mechanics of a bike, how to use several new tools including a jigsaw, a circular saw, and an angle grinder. The biggest lesson I learned during this process, though, was not to set such a big expectation for me when it's a project that I don't have a lot of background knowledge about.